Okay, so there are two types of probability, and this is going to be theoretical probability, and it is what should happen or will happen when a particular action or event takes place. Okay, experimental probability is what did happen when a particular action or event takes place. So if you think about it, theoretical is what should happen. Like I said, if it was a fair world, then that would be true every time. But experimental is what you actually did happen. So you actually performed it, you actually tried it, and then you kept track of that, and that would be the probability. Okay, so don't confuse both of them, because I think that's where students make mistakes, that they're confused which one they're asking for. Now, this example, if you look at it, it's giving you information about a number cube that has been rolled several times, and they're recorded in this bar graph. So if you look at it, they were actually rolled, and 1 was rolled 14 times, 2 was rolled 13 times, 3 16, 4 19, 5 21, and 6 is 17. So now what we need to do is find out how many times they rolled. Now, does it give you that information when you did that? No, it doesn't give you. Sometimes during a question, they will give you the information, and all you have to do is just use that number. But in this case, they didn't give you the information, so what we're doing, we're going to actually add up all the numbers. So let's go ahead and do that first before we even start anything. So that's 14 plus 13 plus 16 plus 19 plus 21 plus 17. Okay, so 4 plus 3 is 7. 7 plus 6 is 13. 13 plus 9 is 22. 22 plus 1 is 23, and 23 plus 7 is 30. So now 3, 4, 5, 6, 7, 8, 9, 10. So that means they actually rolled the dice 100 times. So it's 100 trials. Okay, so based on this information, we're going to go ahead and read what we have to do. So it says, what is the theoretical probability of rolling a 4? Now remember, theoretical means that you're just looking at the dice and it's just what should happen. So how many 4s do we have in a die? 1. So that means it's going to be 1. So that we're going to do the probability of a 4 would be 1 out of how many possible outcomes? 6. Okay, and that's just using the dice. So 1 out of 6. Okay, number 2, it says, what is the experimental probability of rolling a 4? Now, experimental is when you use the graph. So how many were rolled when we rolled the dice 100 times? 19. So that means the experimental is going to be 19 out of 100. Now, we're going to compare the theoretical and experimental probability. So what we're doing is we're going to go ahead and put theoretical is 1/6. We're going to compare it to 19 over 100. Now, can we compare it the way it looks right there? The way the fraction is written? No, we need to find what? Don't we need to find a common denominator? Okay, so what would be a common denominator between 6 and 100? 2? That's a common factor. So remember, when we're having a denominator, we're looking for multiples. So multiples of 6, multiples of 100. So can 6 go into 100 evenly? No, 100 is not divisible by 6. Can 200 be divisible by 6? No. How about 300? Yeah, so 300. So what we're going to do, we're going to go ahead and change that to 300 to have a common denominator. So 6, we're going to change it to 300. And 100, we're going to change it to 300. So now, how many times does 6 go into 300? 50 times. So what we're going to do, we're going to go ahead and multiply the 6 by 50. And we're also going to multiply the 1 by 50. So 1 times 50 is just 50. Okay, so how many times does 100 go into 300? 100 into 300? 3 times. Okay, so then 19 times 3 will give us what? 9 times 3 is 27. 3 times 1 is 3 plus 2 is 57. Okay, now that we have a common denominator, now we could compare. So is 53 hundredths greater than, less than, or equal to 57 300ths? It's less than. So that means that we know that theoretical probability is less than experimental probability. Now, guys, right here, this is the hardest part, right? Comparing it. Just make sure you're finding common denominators. And always, always look for the lowest multiple that they have in common, because that will help you with your math. It won't give you such big numbers. Any questions on that one? Okay, so what we're going to do is we're going to go ahead and do number 4. Now, again, number 4 is still based on the same graph, and it's still based on the same item. So we have a theoretical probability of rolling a 1 or a 2. So how many 1s are in the cube? 1. Okay, so in this case, we have for probability of 1 or 2. So the probability of 1 or 2 is going to equal to 2 out of 6, which is the same as 1/3. Because remember, we always, always, always have to simplify our fractions. Okay, now what we're going to look at is the experimental probability. So how many 1s did we roll? 14. So the probability of 1 was 14 over 100. What's the probability of 2? 13 over 100, right? So then what we need to do is add the numerators. So that's going to be, so the probability of 1 or 2 is going to give you 27 over 100. Okay, so what we're going to do is go ahead and compare them. So now we're looking at the probability of 1 or 2. So we have 1/3 compared to 27 hundredths. Okay, so again, we do need to find a common denominator. So what's a common denominator between 3 and 100? Is it 200? It's still 300, right? So let's go ahead and change that to 300. Okay, so 3 times 300 is times 100. So this is going to be 100. And then 100 times 3 gives you 300. So 27 times 3. We're going to do 3 times 7 is 21. 3 times 2 is 6 plus 2 is 81. So is 100 greater than, less than, or equal to 81? It's greater than. So in this case, we know that theoretical probability is greater than experimental probability. And only in this case. So if you notice, it's not always going to be less than, it's not always going to be greater than, and it will be sometimes equal. As long as you're simplifying your fractions and finding common denominators, you will be able to do that. Any questions on any of that? So that's review from yesterday. We actually worked on it. We tried practicing it. We're going to continue practicing that. But we have one more thing on probability, and it's predictions. So what we're going to do is the bottom of your foldable from yesterday, make sure you have that, and we're going to go ahead and write down the making predictions on the bottom. Now, how many of you remember how to find a missing number when you have two ratios? You guys remember the one chart? Or the probability chart? That's what we're using today. Okay, and remember, you fill in the spots and then you do cross product or you find a scale factor. And that's what we're doing now. So we're going to start with theoretical probability. So if you look, we're still looking at the bag of marbles. So what would be the theoretical probability of a black marble? One out of 6, right? Okay. So then they're saying that instead of 6 marbles in a bag, now there's going to be 180 marbles. So what we're going to do is we're going to go ahead and use the one chart or the proportional chart. So this is going to be black marbles to total marbles. And it's always going to be total on the bottom. So make sure you remember that. So we know that it's going to be 1 out of 6 if it was just that bag. But if we have a total of 180 marbles, then all I have to do is find out how many marbles will be black marbles. So what do we need to do is find a scale factor. So 6 into 180, it will be 30, right? So then 1 times 30 will give us 30. So that means there will be 30 black marbles in the bag. Now, do you guys remember that? Yes? Okay, now that was using theoretical probability. You could also use experimental probability for predictions. So again, we have here the experimental probability that we used yesterday. So how many total trials did they have here? 30, right? Okay. So now they're asking us about black marbles. So what would be the probability of a black marble in this experimental? So it's how many? 2 out of 3, which is, it's actually 20 over 30, and then you simplify it to 2/3. And that's what we had yesterday. So now we're going to go ahead and use that chart. So we have, again, black marbles over total. So we have 2 black marbles for every 3 in the bag. So if I have 180 marbles now, what would be my scale factor? Times 60. So 2 times 60? So that means there's going to be 100. Wait, we did it wrong. Because it was supposed to be 2 out of 30. Do you guys see that? Black marbles. We were thinking striped marbles yesterday. So, okay, let's go back. So this is going to be, there. It's going to be 2 out of 30, which is 1/15. Or we could do 30. That way it makes it easier. So 2 out of 30. So how many times does 30 go into 180? 6 times. So 2 times 6 is going to be 12. So we actually just used the wrong number of probability. Okay, so let's correct this one because that's supposed to be 2 out of 30. Okay. Any questions on that? Sorry for that mistake. Okay. Yesterday we did striped marbles. You guys remember that? But now they were asking for black marbles, so that's why we did it wrong the first time. Okay, any questions on predictions? As long as you could set it up with the favorable outcome on the top and then the total, then you should be fine. So any questions on this? No? You guys got it? I know it was a lot. Yes, a lot of it was review from yesterday. So hopefully you understand it a little bit better. So this is going to be your assignment. I'm going to go ahead and give those to you. Make sure you're working on it. Remember, if you turn it in early, it is 10 extra points. So make sure you turn it in. And if you need to watch the video, it will be in Google Classroom again. So make sure you do that.